today's goal is I want to basically go through sort of some of the key steps. I want to go through some of the key steps of sort of like what it takes to actually make an AI product. And I think that one of the things I see is a lot of people learn how to do MNIST, they learn how to build a basic model, they learn to do stuff, maybe in Jupyter Notebooks, but then they don't think about actually sort of taking a basic model and transforming that into an actual AI product. So I want to sort of discuss some of the real world challenges, and I'm actually going to do it with a real world example that I built about 10 days ago. So I gave this talk last weekend in Bangkok at the AI Day there, and I built this just a couple of days before that, so you'll see how it goes. Anyway, so Google, pretty much all of Google's products now contain some form of machine learning or deep learning. One of the classic examples was, there's this slide that's actually very old now. This is almost coming up on almost 2 years old, that shows the number of repositories inside Google that basically have a machine learning or deep learning or ideally TensorFlow in that repository. And it's well over 6,000 now. I think it's getting close to 7,000 or more already. And basically, deep learning is now being used inside Google for all these different products. And certainly, the reason why I sort of show this is to show you that, Google is definitely leading the way, but everyone else is following behind. And you're going to see more and more that most products that are sort of digital products in some way will use machine learning. You've got companies like Netflix who are making extensive use of this sort of technology. You've got all different sort of fields doing that. So what I wanted to do today was basically look at, okay, what are some of the challenges that you have when you're building an AI product? And the first one may sound a bit silly, but this is one of the most important ones, I think, is that just can it be done? Is it something that's even possible? So we get a lot of people asking us, oh, can you build something that does X? Which is just, like, can you build something that, they might as well be saying, can you build something that can read people's minds and then predict the stock market and do all 25 other things in one shot, right? And so the big thing you want to do is see, like, okay, is it possible? And so one of the other things you want to ask yourself to sort of justify that question is, has someone else done it before? Another big, and sometimes you'll see that, that just because someone hasn't done it before doesn't mean you should, stop. But you should be wary of, things that maybe haven't been done before. Is there data available? I think this is one of the key questions that we're constantly asking clients or people that we work with. Is, you find time and time again that what people want to do is actually quite doable if they had the right data, and you sort of end up saying to them, well, your business could collect this data, but you need to go away now and collect this data for the next 6 months to 12 months, and then come back with it before we can sort of do something with it. The other sort of questions you ask yourself is like, okay, can you find or synthesize the data? Especially if you're a startup, you're often not going to have a lot of data at the start. So you're going to be looking for ways to synthesize data. And some of the key things I just wanted to sort of point out was that these sort of ways of looking at things are very different than sort of just building a model to learn about machine learning, and also it's very different than academic sorts of things of building a paper to be at NIPS or something like that. So the way I like to think about it is, can this task be broken down into component parts? One of the biggest sort of myths is that people think that, okay, just because they learn about end-to-end models, that in industry, everything's end-to-end. Usually not the case, right? Usually you have different parts or different models doing different things. The other question I like to ask is, okay, well, what's your problem like? Is it a classification problem? Is it a regression problem? Is it a generative problem? You'd be surprised that a lot of things that will look a certain way can be sort of refactored or changed to be a different way. A classic example of this would be Smart Reply inside Google. So the first paper for Smart Reply, first of all, this started out as basically an April Fool's joke in 2009. That, okay, Google made this product that would just reply to your emails. Then people started to think about, okay, well, maybe this could be done. And the first sort of academic papers that were looking at this would doing it as a sequence-to-sequence generative model. So it would basically read your subject line, it would read the text of your email, and then based on that, it would generate a bunch of text for a reply. The problem with this was that it would generate 3 replies, and it turned out almost always that one of the 3 replies was, "I love you." Because it was just safe, right? And the model learned that, okay, if it put that, that was a safe response for a large proportion of things. To get to the actual sort of production version, and again, this is an older slide, and I think actually Smart Reply now on mobile makes up about 30% of all replies. It needed to be changed, and what happened was they actually changed it to moving from a generative problem to being a classification problem. That it basically looks at your email and decides, okay, for these responses, I will pick one of 29,000 different classes. So it's moving from something that's sort of infinite to something that's very finite. And I must admit, when we first heard about this, we were quite disappointed because the academic paper was so amazing at the time that we thought, oh wow, if Google's actually got this working, this is going to, could be a really big step along the way to, a whole bunch of different products. But it turned out in the end that, okay, it was just turned into a classification problem. And this is something that's very common when you're building products like AI products for the real world. Something that will seem to be sort of like totally generative, when it actually makes it out into the real world, it becomes very, becomes a classification or something much simpler than what it was in the academic sense. So, okay, this is what I wanted to start out doing. So I remember reading about this paper. I don't know if you guys read about this last year, and I thought, oh, this is really cool. At some point, I would like to do this. So probably about 2 weeks ago, I started actually reading the paper and thinking, okay, well, how am I going to implement it? Look at some of the examples that were out there. And what this basically is you draw a picture of a website and it turns it into code. And it basically just takes your drawing and it works out, okay, how will it represent that in HTML? And this is the paper that it came from. And the original one was Pix to Code, where they basically tried to do for HTML, they did it for, I think, XML for iOS displays and for Android displays. For me, I just focused on the HTML part. Now, one of the first questions I always ask myself is, well, what is this like? What kind of problem is this going to be compared to other things that I've seen in the past? So the classic one that this is basically like image captioning. So you may have seen this, a year or two back, the whole show and tell concept of where you basically train up a model so that it looks at an image and it writes a caption based on what it sees in that image. And you can see that it's pretty amazing that it has the ability to look at this picture, and even though we can't sort of see any sort of string or anything between the human and the kite, the model is able to work out that, okay, if the person's facing the kite, if the kite's a certain height in the air, then it probably is the person flying the kite. And given enough data, both images and enough captions, it has the ability to, you build the model so that it has the ability to learn to do this. So this is something that Martin and I were both very interested in a bit over a year back now. And actually Martin showed a good example of doing this with what's become now a famous paper, Attention is All You Need, at our TensorFlow meetup. So I encourage you to come along, because often we show very cutting edge things there. So this is the first thing that I thought, okay, well, this paper is kind of like this. The second one is that the whole idea of that if you basically use some sort of RNN or LSTM, you can generate a config file. So the slide here comes from a paper called Neural Architecture Search, which basically led to NASNet, right? Which James was talking about, this current state of the art in ImageNet models is NASNet. And the way that this model worked was, I can't go into all the detail, but one of the key parts of it was that it basically had this RNN controller that would predict certain parts, which would then become like a config file, which would then get turned into basically a network. So for example, you can see there it's got like the number of filters. So here it's predicting one layer of a CNN. And it's basically deciding the number of filters, the filter height, filter width, your striding. And what it would do then is it would basically take that, just very quickly about NASNet, what it would do is it would take that, it would then build the model, train it up, and then check the accuracy score, and then use reinforcement learning back to feed into the RNN as a reward thing. So then over time it would change. But the key concept here is that I was interested in was this concept of basically you can take some sort of RNN and you can use it to make a config file. And that config file could be used then to build something like an HTML file. And so another thing that this could be like that you can think of is I'm sure many of you have played around with char RNNs. How many people know the model char RNN, where you basically build a recurrent neural network to predict the next character of text, and maybe you've done it with Shakespeare, or maybe you've done it with some sort of text, and you find that after a certain number of iterations, the model has the ability to actually predict readable text after a while. So these are the things that I started out thinking, well, this problem is kind of like that, because we're taking a picture and we're going to turn it into some sort of config file, which I'm then going to turn into an HTML file. So let me sort of explain a little bit about the thing. So there's two key sort of bits of data that we're going to input. We're going to input images, and we're going to input sort of GUI configs. So the GUI config, and I'll show you a picture of one later on, is basically just a representation of an HTML page in a much simpler format. Then the model that I'm going to use for this is basically a convolutional neural network going into one of these LSTMs. So we're going to basically extract features and then go into that. The GUI file is basically going to become sort of like our vocabulary that we're predicting. And then last of all, we're going to use really something that's not deep learning based, but just simple coding based, is this compiler. And this compiler will basically take our predictions out and then use those predictions to turn them into a proper HTML file. So another way, if you can look at this, is you've got your CNN. Your CNN you can think of as being like a feature extractor. It's looking at that hand-drawn image and it's trying to determine, okay, what are the key features in here? Then that's going to make the configs, so then we also make some configs and we tokenize them. We then put both of those into a model to basically train an LSTM to come out of this. And then last of all, what we're going to do is, as we're coming out, we're using a softmax just to simply predict, we're turning this into classification now, simply predict what is the next token based on what we've seen already. So and then we take those tokens, we call those tokens the domain-specific language, and we convert those to HTML. So let's actually look at sort of a picture of the model architecture. So here you can sort of see, we've basically got an LSTM and a CNN going into an LSTM, and that's going to predict our domain-specific languages, and our tokens in that case. Then we're going to basically, when we're doing inference, we're just literally going to put in the image itself and rely on that to extract the features and to bring those out into our sort of LSTM, and that's going to make our config file. So another key part of this, I've kind of touched on this already, is the compiler. So this is sort of like a real trick of the trade that you see for a lot of these sorts of things. And if we were, how many of you know LSTMs and RNNs? Quite a lot, right? Okay, good. So if you've dealt with LSTMs and RNNs, you know that they have a very limited amount of prediction power, meaning that there's no way we could really train an LSTM to predict, 1,000 characters of an HTML file. It's just not going to be that, accurate at doing it. And it's certainly going to fail at things like learning to open and close different tags or learning to do that kind of thing. So we need to produce this sort of config file. And that's what I was showing you before with the NASNet slide. And then we have this domain-specific language, these tokens, that are going to represent and be compiled into the raw HTML stuff. Right? So this is what an example of a config file looks like. So each one of these is a separate token that basically the network is going to be able to predict. Now, of course, remember, these are going to be then tokenized and turned into numbers and fed in. But when we make the prediction out of numbers coming back out, this is what we want to get, something like this. And you can see this has got a start token and an end token. So any of you who've worked with any sort of NLP in deep learning or any sort of sequence-to-sequence stuff, this should be quite similar to things you've seen before. We then take that GUI and we basically have to then use a template to basically turn that back into the HTML. And so this GUI basically, this config file just represents chunks and snippets of HTML, if you think about that. And it's just going to basically stick it all together. And one of the things that we need to have, though, is a template file. So we have a template file that is mapping from those tokens that we're predicting to actual raw HTML in this case. And you can see that we've got, for example, an opening tag, a closing tag. We've got different things for a header, for a button, for a few different things like that. Okay, data. Now this is where this becomes a real challenge. Is that synthesizing data is one of the biggest challenges you're going to have in making any sort of AI product. Usually, you're going to have to find some way to make data at scale if you're going to make a commercial product. It's a very well-known secret, I think, that Google, Baidu, Facebook, etc., often will make products just simply to gather data. Right? This has become very controversial, obviously, with a lot of the things going on with Facebook recently. But Andrew Ng has talked about this, that at Baidu there are a number of products that they've made with no intention of making any money out of that product, that it's a loss leader purely to gather data. And if you can do something like that for your particular situation, that's something you definitely want to do. This will usually be one of the biggest challenges you face in making AI products. You then also often have to build your own tools to annotate data, or to be able to find some way of tagging data. Another thing I don't have time to go into today, but you can also use some sort of unsupervised learning or semi-supervised learning way to actually take sort of raw data from the wild and label that or turn that into something. Obviously, the more data, the better. But the data must simulate, in this case, for example, the data had to simulate what someone might draw. And another just really sort of simple tip is that this model crunches that image right down. But when you're gathering data, try and get it at the highest resolution possible, because you never know when you're going to want something that's higher res. And in this case, I actually got 2 of my staff to just sit there for 2 days and draw pictures, right, to get the data. And if I had then gone back to them and said, oh, sorry, the image is not, high res enough, they would have been pretty pissed off at me having to do that again. So in this case, we needed a lot of hand-drawn stuff. So one of the things I did try with this, which didn't work, was trying out different sort of CSS, styles or different ways of actually making it. So this is sort of one of the things that I found on CodePen, was a way to basically try and make buttons look like they were hand-drawn. In the end, though, this didn't seem to work for what we were trying to do. If I was doing this probably further on, I would maybe look at even building our own sort of CSS stuff to make some way of being able to just suddenly churn out, 100,000 web pages. But what we did was draw them. So these are some examples from a test set. The train set's basically the same sort of, very sort of similar sort of stuff. And you can see that the idea is just to get an understanding of, okay, where the key parts of the layout of the website go. So, prototyping. The next thing, once you've got your data, once you're starting to build the model, you've got to start then thinking about prototyping stuff. So, you want to map out the sort of product workflow. You want to sort of keep about, creating each part of it and stuff like that. The big thing you want to do though is you just want to get something working. Ideally for me, it's in a Jupyter notebook, so that then I have something that I can basically, take to people and show, basically test to see, does this work or does this not work? The other key thing though you want to think about is, and have it in the back of your mind, is, okay, what's going to be my end UI for this product? What am I actually going to, how are people actually going to interact with this product? So let's have a look. How's that for size? Okay, so this is the sort of prototype that I put together for in a Jupyter notebook. So I'll walk you through it. Well, we basically, so I built the model, right? I've got the model, I'm just loading the model. I did the whole thing in Keras just to show that you can build something like this in quite a simple thing as Keras. And certainly I would encourage you, if you're using TensorFlow and you're new to TensorFlow, use Keras, right? It's very simple to start out with. As you get better at it, you then could graduate to other things. So we've got our model. All right, I'm going to load up an image here. And here's the image. Now, you can see that what I'm actually doing is crunching the image down to actually just 256 by 256. So when I tried building different versions of the model at the start, I used, very similar to what James was talking about, I was using transfer learning, and I built basically, I just started out using different models. Started out using different models to see, like, okay, what would work. In the end, it turned out that the ImageNet models were probably a bit too complicated for the feature extractor that I needed. So I went with a sort of simpler network. But I stuck with the, the whole sort of size, just like the paper where they stuck with the 256 by 256 and 3 channels deep in this case. So then we've got the tokens. So these are the tokens that I've got. And you can see basically now I'm just doing a sort of lookup table to map the token to a number, which I'm going to feed in. I then need some way of actually sort of generating those, those predictions. So basically what we're doing, for those of you who are not used to this sort of model system, I'm basically making a prediction of one number, then I'm passing that number back into the network to predict the next number. So I'm predicting one after the other, so I will get a sequence. And you will see that actually here. So if I run this, we can see that what it's doing is it's predicting each one out. Now it's basically predicting that as a number. I'm using the lookup table to change it back to the GUI in this case. I then just write, so then that's really the key, the key sort of deep learning part has already happened there. We've basically extracted the features from what we passed in. I'm saving it, and then I've basically got the compiler set up to actually generate it into HTML. And this is the HTML that it generates. Let me look. So this is our prediction. Let's see, how did it compare to what we put in? Not bad. Okay, so if you were like me, you'd be very suspicious that, oh, Sam picked one that's just going to work. So what I did then was I basically thought, well, okay, really we want this in some sort of web form, or we want some way that people can draw it. So I'm going to do one on the fly, and I'm going to be drawing on my trackpad, so it's not going to be very good. But let's say I draw a few buttons. And this doesn't always work because it's still very much in prototype phase. 3 or 4 buttons. Let's go for 4. All right. And then I want to have sort of one long box. Not exactly neat. We have a heading. We want a bunch of text there. Uh-oh. We have a button. I tell you what, actually that's too similar to the one that we already did. So let's add some more stuff. We can add now you'll notice that one of the things I've got in here that I've actually added in is the page style. So we can actually then sort of say to this, we can pass in an argument or a condition of what type of page, what type of page do we want this to be. So that really relates to sort of like the CSS that we want to pass in. So I'm going to, for the first one, I'll do Bootstrap. And then basically press my create HTML. And you can see this is definitely not as neat as the one that, the training examples or even the test examples. Okay, let's press it and see. All right. So, did it get the buttons right? Yes. When I did it last week, it added an extra button for some reason. I'll just quickly go along and show you, though. We could actually add even more to this. So the model can actually take quite a bit. And this is sort of just to talk about this while I'm drawing. You want to sort of stress test your product, right? In the real world, people would, are not going to draw nice and neat. All right, so there's no point in sort of trying to, draw neat or anything like that. You want to basically do it as much as a real world scenario will do. And this is one of the challenges that I see with things like, I work a lot in things to do with dialogue and stuff. And people, when they build chatbots, will think that humans are going to respond one way and humans respond a totally different way. All right. So you always want to try and gather as much data as you can from the wild. And actually one of the things I actually put into this is that every time I draw something here, or every time we create an HTML page, we actually save the image as well. So that then if we were looking at it and saw that, okay, it got this one right, it got this one wrong, we could actually go back and sort of use those as training data for things going forward. And this is a really common sort of thing for that Google does, that a lot of other big companies do. So let's try material design. I don't know how well it's going to do with material design. All right, let's create HTML. It's thinking. Another challenge with this is that, okay, for example, this response time is just way too slow for the real world. So if I was going to release this as a startup or as a product or something like that, I would definitely need to be looking at optimizing for speed. All right. All right. Did it get it all right? Yes. Okay. Let me go back to the presentation. So, where to from here? So, okay, I now got, something that's a prototype. If I wanted to take this into production, there would be a whole bunch of different considerations to think about. And this is where you're going to be working with product managers, with, other types of people who are maybe not going to know a lot about the deep learning or your machine learning or any of that sort of tech. But for example, would this product be better as a mobile product versus a web product? In some ways, I think I could probably sell this as maybe an iPad app, or something like that. Or what this product might be good is making an iPad app for some sort of web hosting services to give away for free, but it only generates files that work on their web hosting, that kind of thing. You want to think about microservices versus monoliths. I'm not going to talk about that much today, but generally you want to sort of, with a lot of these sorts of things, you would want to have the TensorFlow running on maybe a microservice or on TensorFlow serving, like James talked about. You would want to think about, okay, you're going to use a GPU or not. Obviously, the reason why it was taking so long is I was doing the inference on my CPU here, so therefore it was taking a lot longer to actually work. If I was doing that with a GPU in the cloud, I could get the speed much quicker, but then also I need to think about, the cost per API call. And especially if I'm doing something at scale, those sorts of things become really important. Your model size. You always want to be optimizing for smaller models, faster models. One of the tricks for doing that, we don't have a lot of time to talk about today, is you often train a big model and then you train another smaller model to learn from the big model. And that's a way of being able to get around a lot of those things. So if I was doing a mobile version of this, I definitely want to be using something like TensorFlow Lite or Core ML. If I wanted to make it for, I could also then add in the bits for iOS or for Android, meaning that I could actually make layouts for Android apps or for iOS apps. One of the things I wouldn't personally do this, so I actually have had a lot of experience in mobile. Certainly on iOS, no one really uses the stock Apple widgets anymore. People tend to make their own. So I kind of feel like that wouldn't be a big advantage in doing that sort of thing. If I was making it for the cloud, where would I deploy those HTML pages to? At the moment, it's still just all running local. Business considerations. This is one I think is really important. Just because you can make something that's technically great doesn't mean people will use it. And I actually kind of feel that this particular product falls into that category. That I kind of feel like it's a really cool gimmick. And it looks really cool, but how many people would actually use it to design their website? Probably not many, right? So you always want to be thinking about, will people pay for this? I see this all the time when I'm mentoring startups and stuff, that I see often they will make something that's maybe technically very great, but really in the real world no one's going to pay for that product. Again, is it a painkiller? Is it a vitamin? It's kind of, does the ML or AI shine more than the actual product? This case, I think it does. And I'll tell you, a perfect example is like when I show it to you guys, you understand that, there's a lot of, hardcore deep learning going on there. I show it to the average person on the street and it gets one button wrong and they're like, it sucks. It doesn't get it right. So you want to sort of think about, those sorts of things. From a more research perspective, the other thing that I think would be really cool for this is you could actually develop a GAN to do this. This is maybe something I will play around with in the future. You could actually build a GAN for both making training images and also for making the different types of GUIs. You could also build a really cool system to be able to basically just go out and crawl current websites and use that to make training data for you, so that people could actually do things. Another thing is that I would definitely want to add more tags to this. So at the moment I don't have any sort of image tag. So really what I should do is have a box with maybe a cross through it, and that would be showing that, okay, we want an image there or something like that. Anyway, some tricks of the trade. I follow Google's example, play to your strength. Google is definitely the king of search, and they tend to turn things into a search problems as much as possible. While I've signed a number of NDAs with Google, I can't tell you, sort of anything secret, but I would say that, one of the things that we've definitely learned over time is that Google will often turn things into a rank and retrieve problem or some sort of search problem rather than just a straight out prediction problem. So that's something that you should definitely think about. And obviously Google Home really is just a big massive search engine in many ways. Play to your data. Make things that you either have the data for, can get the data for, can steal the data, or can create it. This is by far, when you see AI startups and stuff like that, it really comes down to, okay, do they have the data? Do they have a unique set of data that will allow them to do this sort of stuff? Medical data can be really hard to get, yet so many people I see trying to do the medical thing and the radiography thing, really when a lot of the models now are just becoming like off the shelf, you can take the best model from Kaggle, it really comes down to who's got the data to be able to implement that. Getting millions of examples of something that you need from the public is really, really hard. So that's something that you also want to think about. And that's it. I'm happy to take some questions. There's some links to the original paper and original implementation of the paper as well.